Okay. Good morning, Gabriele.
Good morning.
So we give some time for the participants to connect. I see them coming in. Slowly but surely. Maybe you want to just start to slowly introduce Gabriele.
Sure. Why not? We have 9 participants, so we can start and welcome everybody to this webinar about safe and secure communication. This is one of the many topics that we cover during this kind of events. Considering the good feedback that we received so far from our participants, we continue sharing our knowledge regarding intrinsic safety and functional safety. Just a brief introduction about myself. I'm Gabriele Caglio. I'm a technical support specialist here at GMI, and we have Tino van de Capelle, which is the functional safety expert and today's main speaker.
Okay. Can you move the screens, Gabriele?
No,
It's
I
not
can see a
working?
red dot.
Although I give you control, doesn't matter. Okay, I will slowly move on.
Okay, so yes, thanks. So an introduction of GMI for whom that doesn't know us. GMI is an Italian company providing field interfaces related to intrinsic safety and functional safety. This means that it is possible to find GMI devices in many industrial packages such as ESD, DCS, ESD, fire and gas, and so on. And as you can see from the screen, we are talking about oil and gas, petrochemical, pharmaceutical, mining, but also food and beverage and many other industries. We have 40 years of experience in the field. The headquarters is in Italy, where we have our main facility, and there we design, produce, and test all our products. We have several offices and resellers all around the globe, so we are available pretty much everywhere to stay close with our customers. As I mentioned before, we are a safety company, and we aim to provide safety and reduce the risk of hazardous events to safeguard people, assets, infrastructures, production processes, and the environment too. For this reason, the quality aspect of our product cannot be overlooked. We design our product, we manufacture and test 100% our devices internally, meaning that we do not outsource any of these tasks. This is why we are confident about the quality of our products. A couple of more slides before to get to the real part of the webinar. This one is about the certificates, or at least the certification bodies that we are dealing with. This guarantees the quality of the devices, but also guarantee that GMI products comply with the market requirements according to different local regulations.
Okay.
Our portfolio, a brief overview also here. So as I mentioned, we have intrinsically safe barrier. We have safety relays, SEAL certified, with and without line monitoring for energized to safe and de-energized to safe application. We have isolators. We have AX power supply system up to SEAL3, temperature and digital multiplexer for Zone 1 installation. We also have customized termination board for an easy connection to the main PLC and DCS system. We have ART multiplexers, surge arresters, and we also provide consultancy, and we share our experience through courses related to functional safety and intrinsic safety. Final slide is just a list of some of our customers, which stretch from system vendors to EPC, OEM, and end users. Final thing about the webinar, this webinar is recorded. So in a few days, you will find it available on our YouTube channel. Subscribe if you want to get a notification. You will get a link to download the PDF copy of this presentation also in a couple of days from now. You will also get a certificate, but only if you attend at least 75% of the webinar. If you have any questions during the presentation, you can write it down on the Q&A session, and we will try to answer as soon as we can. And I think it's enough. So please, Tino, go ahead.
Okay, thank you, Gabriele. Thank you, GMI, for giving us another opportunity to select another topic. And as you noticed, for those who were here before on the webinars of GMI on the topic of functional safety, we selected today a new topic, which is called safe and secure communication. And this is purely based on, we had recently various engineers asking some questions concerning when is a communication safe, or how do I keep it secure, and does it make a difference to what network that I'm using, etc. So that brought us to the idea to create a webinar for it. And I split this webinar into two main parts. One is being related to safety. Safety will be, of course, to the functional safety standard called IEC 61508, which is the manufacturer standard. And then the other topic, or the other part of the presentation, will be concerning security, and I will use the OT security standard today on the market called the IEC 62443. As Gabriele was already mentioning, you can, if you do have additional questions, you can actually write them into the Q&A box or in the question box. And then if I notice them on time, I can try to answer them. If not, we have to do it later. What also happened was during the registration, some of you came up with some quite interesting questions already. And I always have the liberty to select the most, let's say, important questions. Like if someone asks what will be the weather today, well, I don't even tend to answer that. But if someone asks a related question to the webinar topic that we are presenting here today, then we put the effort in to also prepare some questions. So I picked up 3 questions, and that will be shown after this webinar. We'll go to the Q&A, which is pre-recorded, which is already pre-registered, and I actually will give you some answers to that. First topic for the communication is the safety business, or the safety question. When does something is considered as safe? Well, we always go back to the original standard of functional safety for anything which is electronic, electrical signals, or programmable electronic systems, which we abbreviate here in the title as an EEPS. So the 61508 is mainly used like company like GMI when they are planning to develop a hardware/software subsystem device. That device, enabled to prove compliance to a certain SIL integrity, will show through an assessment, and most of the assessments are done by third parties. Well, those assessments will be then giving you a result that you can use this device for a SIL 1, SIL 2, SIL 3, or for a SIL 4 environment. So the main standard is always the 61508. And as I already mentioned, any safety product supplier, including GMI, that wants to prove to the outside world that their equipment can be used for a, let's say, functional safety business in terms of safety integrity level. And like Gabriele was saying, like all the barriers, isolators, and safety relays, even some power converters or supplies from GMI have SIL 2 and SIL 3, let's say, compliance assessment evidence. The hardware part of the standard, I mean, the IEC 61508 consists out of 7 parts. And in part number 2, which is the main part for the hardware developers, that is where they will be told what should they consider before they can actually prove compliance to a certain SIL level. And of course, the higher the SIL level, the more restrictive those requirements will become. And part number 2 is hardware, the same for part number 3, that is considering then software. So if the devices have some firmware that plays a vital role in fulfilling your safety function, well, then that firmware needs to be developed according to part 3, which is a software section of the normative sections from the IEC 61508. For those who are maybe not so familiar with the IEC 61508, it has 7 parts, but only 4 parts are normative, which is part 1, 2, 3, and 4. Part 2 is hardware, part 3 is software, part 4 are the abbreviations, term and definitions, and part number 1 is a general framework of the standard, including the functional safety management. Part 5, 6, 7 are nothing more than additional examples and guidance on how to use the normative section of the standard. If you go into details for communication itself, and I did some, let's say, some homework before I started to create all those slides. In the normative section, part number 2 of the 61508, they are requiring an estimation of the failure measurements for any communication processes. And they actually ask in the standard to be able to identify or to detect transmission errors, repetition in your communication, deletion, insertion, resequencing, corruption, delay, and masquerade. So in other words, it's very clearly detailed specifying the standard from a safety point of view. If one of those failures would jeopardize your communication data packets to be safe understood by the other end, well, that could cause an unsafe position. And it's those failure measurements that needs to be accounted for when you estimate the overall failure measure of a safety function towards random failures or random hardware failures. The measurements are split into 2 topics in the IEC 61508. And the methodologies and the actions required to achieve a specific failure measure, such as, for instance, a error rate of the communication processes, allow those 2 approaches where they are known in the standard as a white channel approach, and I will then explain you, of course, what a white channel approach really means, or the black channel approach. For any end user or any engineer from an engineering contractor listening into this webinar, you are dealing mainly with black channel approach. The white channel approach is mainly dealt by the developers who are inside one system, who are communicating, as an example, from one communication rack to another communication rack, as long as it's all by the same vendor. But if you are connecting your transmitters, or if you are connecting another device, which is connecting into a safety PLC as an example, and you're using things like, for instance, ProfiSafe, well, that is all based on the black channel approach, which I will show you again some examples from. Starting with the white channel, that's the most easiest one I hope to understand. Everything is in the same kitchen. In other words, you have different cooks preparing different recipes, but they're all in the same kitchen. That means it's all controlled by the same system. If the system is actually under the 61508, let's say, definitions to be designed, well, then under this method, the entire communication channel must be designed, must be executed, and must be validated in according to the entire layout of the 61508. As well as, and they refer to 2 different standards here. One is called the IEC 61784, which is on the bottom, you can read this here, that is the functional safety standard for field buses. And then we have the IEC 62280, which is actually to do with software engineering for railway control and protection systems. As you can imagine, also in railway, there's a lot of communication, even on a train, as an example. Well, also that has been described in a dedicated specific standard. So if I go back to the white channel approach, what do I want to highlight is the middle section over here. You see there is an element compliant towards the 61508, and it wants to communicate to the other side, on the right-hand side, to another element that also complies within or with the 61508. Well, the entire communication channel, including the interfaces, needs to comply also to that 61508. That is where you see here these 2 blue barriers. I call them here a barrier. Well, those 2 blocks, what you see over here with a dotted line between, that's your communication. As long as the entire communication, including those barriers or including those measurements, resides inside a 61508 compliant system, that is what we treat as a white channel. I give you another simple example that you may understand easier. If you buy a safety PLC from vendor X and they have a CPU rack communicating to an I/O rack, that means they have multiple I/O racks. Well, as long that safety PLC vendor X is communicating with his own modules to another rack, They will use their own communication protocol, and they will use their own channel communication. That means it's all based on the white channel approach. The second one is a black channel approach. And a black channel approach, you see, we deleted here the middle section. That means we're going to use something which is not inside a 61508 compliant device. And the black channel approach by the IEC 61508 is then asking to look into those countermeasurements or those protocol checks which are over here in those barriers. And those barriers are now inside the element which is compliant again to the 61508. And what do they ask here? That the interfaces needs to comply with those two standards, either the functional safety standard for field buses or the railway standard. And if you communicate then from left to right or from right to left, it can be bi-directional, as long we go and use that specific protocol, and the protocol has been written according to 61508, that is what we can refer to as the black channel approach. That means part of the communication channel between the interfaces does not comply to the 61508. So in contrast to the white channel approach, where everything was inside the same, I called it kitchen to simplify my explanation or my example. Well, if you're not inside the 61508, you need to make sure before it leaves the 61508 compliant element that you're going to use a functional safe protocol that needs to be recognized on the other side, and also needs to make sure that the data packets or the message has not changed. That means you still have to take care on both sides of your elements. You still have to take care of those measurements. That means the black channel approach allows parts of communication channel to deviate from the standard specified as in the 61508. However, in that specific scenario, the necessary measurements are the blue ones, which I have indicated here in those two boxes, needs to make sure that the fair performance of the communication must be implemented within the 61508 compliant EEPES subsystem or the elements interfacing with the communication channel. These measures should align with the guidelines provided in the 61784, which is the functional safety for field buses, or with the railway standard. And the last topic that I want to highlight here on the black channel approaches, safety in data transferring using a black channel relies on the efficiency of the protocol rather than the medium used for the transmission. That means the medium we use here in between. If there's a copper wire, or it is a smoke signal to make it extreme, or it is a wireless or satellite communication or field bus communication, the media itself will not have an impact on the protocol integrity that needs to be checked on both ends. The protocol providing the necessary measures to ensure the fair performance of communication must be implemented inside that element which is 61508 compliant. Summary, as I already mentioned, the safety of the message packets is determined by the protocol, whether it is transmitted via wire, fiber optic, Modbus, Ethernet, wireless, or other means. Right, Gabriele, we have a first poll question coming in. So I'll read the poll question. So we want to have some interaction. So just sit there and maybe falling asleep is not a good sign. So we want to have some evidence that people are willing to click a button. There is no prize to win. There is no image to lose or to gain. The question is, which of the following best describes the application of a black channel principle in safety-related system? And only one answer out of A, B, C, D. So only one answer is the most correct and the most complete one. Answer number A, ensuring all parts of the communication channel are physically protected from external interference, describe best a black channel. Answer B, using a dedicated communication channel for each type of safety message is describing a black channel. Answer C, implementing safety measures such as error detection and correction techniques within the end components rather than relying on the safety of the transmission medium is answer C. And answer D is applying the high SIL rating to all components of the communication system regardless of their individual requirements. That is your answer number D. Right, we need a few more clicks, so people are maybe afraid to click. Okay, that is helping. We see them, most of them are all coming in. I think we have a good result, Gabriele, that you could share.
Okay, so let's end the poll, see the result.
Okay, as you can see here, the majority has answered the bottom one, implementing safety measures such as error detection. Oh no, sorry, it is my screen. I have to scroll because the text is too long. So let's do the summary again. You see the first two answers, A and B, have only 13%, while those were unfortunately not the correct answer. And luckily here in this webinar, answer C has been clicked 63% of all the participants following it. And indeed, for those who were focusing and listening to what we just said, that is, of course, the most correct answer, because we need to implement those safety measures inside components which are 61508 rather than, or compliant using the correct protocol, rather than looking at what medium we're going to use in able to communicate from one component to the other component. So the last answer, D, applying the highest SIL rating to all components of the communication system, regardless of their individual requirements, is not 100% correct. It's not 100% fault also, but the thing is here that the trick is we are focusing on the implementing the efficient safety measures based on the efficiency of the protocol. And that is what we're looking for in this answer. Right, let me continue. Second part of the webinar is to do with security. And here we are talking about the IEC 62443. For those who are familiar with this, I call it the OT security standard. That is a standard that was derived from an older kind of guideline / standard, which is called the ISA 99. Now, the ISA 99 from the early days has been transformed into a lot more, let's say, detailed description. That is how the IEC 62443 has been initiated. Now, the IEC 62443 is not 100% totally mature or released yet. In other words, we are still struggling. That although they brought it apart, I mean, the last one was coming out by memory in 2020. That was the famous or infamous Corona year. Now the same part has been under supervision again already, or under maintenance already. So they are working on a newer revision of the same part. So in other words, not all parts have been released. And even if they were released, we still have to deal with potentially new revisions in the very near future. Although it is not mature the standard, it is still the main security standard that particularly safety vendors, like for instance your safety PLC vendors as an example, they will be accredited towards the standard 62443. And you may have seen already some piece of paper called certificate, which has been evidence as an assessment to claim or to prove a certain security level. And we will come back to security levels. There are 4 different security levels. The higher the number, so security level number 4 needs to have a lot more stricter countermeasurements than, for instance, a security level number 1. Now, the framework is very similar to any frameworks in all the IEC standards that you will see in terms of a life cycle. And what the vendors of such type of components or such type of devices will be required to do, they will be required to actually prove a risk assessment and management based on their development of that type of equipment. Later on, the end user will use that equipment again also to do a security risk assessment on the IACS, which stands for the Industrial Automation Control System Environment, where you will have zones and channels, but I do have some slides coming up on this. Then the second bullet of the framework of the standard is looking at security policies and procedures. There's also specific for, of course, the hardware and the software developers. There is some specific item for secure design and implementation of those type of measurements. Continuous monitoring and improvement will be mainly later on by the end users that will need to monitor how good the countermeasurements are still performing. And of course, nothing goes without security awareness and competency training on the engineers that needs to build it, maintain it, operate it, etc., etc. Safety and protocol versus security and countermeasurement. So I left the title here where we just talked about the protocol that can make the communication safe. Here we're gonna actually do just the opposite. Here we're gonna specifically talk about the countermeasurements enabled to keep a communication secure. So similar as we just discussed under safety and protocol, in security we use those countermeasurements and the efficiency of the countermeasurements as actions or techniques to implement, to detect, prevent, mitigate, or respond to security threats and some weaknesses in your design. Countermeasurements are essentials here on components itself of a defense in-depth strategy aimed to protect systems, networks, and data from unauthorized access, attacks, and exploitations. The countermeasurement itself will play a significant role in achieving those security levels so that you can actually achieve your objective for security to each security level. What I already can mention you here is that the safety PLC manufacturers today on the market, they reach a maximum security level equal to 1. And in the majority of the process industry fields, that is typically not sufficient. That means you as an engineer, by the end users or by design in an engineering team, will have to come up with additional countermeasurements to make the security level 1 of a safety PLC vendor solution maybe into a security level 2 or even maybe security level number 3. Security levels, as already mentioned, there are 4, which provide guidelines for industrial automation control system security. That's the IACS abbreviation. Security levels will categorize with the required security measures based on the potential impact of security towards your zones in your installation. That means towards safety, operational measurements, and also, of course, economical aspect of a system. You can imagine when they, for instance, can go after a power grid, and they could attack a power grid in a country to turn it down, that the entire country is without power. Well, that will have a certain economical impact, even not only economical, it will also have a certain image impact for that company providing the power to that country. There are 4 levels. SL1 is the lowest one. That means that will be the basic security measurements applied to protect against casual or coincidental violations of security policies, whereas the SL4 is the highest one. The SL4 will be the stringent security measures enforced to protect against highly sophisticated attacks carried out by determined and capable adversaries. Means that if you have an SL4 requirement, it means you have an army of specialists trying to hack into your systems or trying to do something that you would not appreciate or like onto your installation. That is the highest level security SL4, which we have not seen yet in the process industry. To give you some idea what is a channel and a zone, I took here a picture of one of the guidelines that we are using, and I was just looking at the reference. I was supposed to put the reference of the guidelines underneath, which I totally forgot. I see now. Doesn't matter. The zones itself can be physically your SIS system. That means your safety instrumented system, which all the webinars are typically related to, of course, 6.15.11 related equipment and systems, including also the material from GMI. They can also have your BPCS, which stands for your basic process control system. And very often now there is some communication between those two systems in the modern installations. Of course, here on this picture, we don't show any communication other than here a hardwired concept, a discrete wiring between in and out or I/O between the two systems. And here you see your control center, which can be your control room, where you actually will have the window to your process. Your process is here below. And you can see here between the zones, we show here the green, we call that the channel or a conduit. And before the communication of a zone is leaving on this conduit or channel to go into another zone, you see here a brick wall, which could be like a firewall as an example. Well, that is what they will identify as your specific efficiency of your firewall or your counter measurements. And typically when I'm giving that type of training course, we're also doing the security risk assessment course and a combined course, which I will show you later on. We typically explain that imagine you have to go from two countries into another country, and there is a bridge in between. And since my background is very heavily related or influenced by the Middle East, if you go from Bahrain into Kingdom of Saudi Arabia, you can take the causeway, which will have a counter measurement before you leave the country called Kingdom of Saudi Arabia. And before you will be allowed to go on the causeway, you will have to go through some security checks. And once they allow you to drive your car from one country to the other country, so you're on the causeway, there is no check anymore done when you are driving on that causeway. But before you enter the other country, which is called Bahrain, there will be another counter measurement again to check before they will allow you to enter the country. Well, those two counter measurements or security checks on both countries, that is the example here, what we also use in that communication with those two firewalls on both zones. So zones can be anything from an enterprise, could be physically a system or a building, whereas the channels is any communication in between. And as we clearly pointed out here, the counter measurements are inside the zones, are not inside the channels. And that's very similar to what we just discussed with the black channel. Your protocol checks, the barriers, which I call them, were inside the subsystems 61508 compliant, where here the counter measurements are inside the zones, which needs to be proven compliant to the 62443, but not inside the channels. Security levels are typically assigned to zones rather than the individual conduits or channels, as I just explained. Channels are a pathway or roads to used for communication between the different zones or components within a system, while channels play a role in facilitating the communication, like the bridge between two countries. If you now go by boat or you swim or you take an aircraft, security measurements will be in the countries before you leave. Of course, if you say, well, we're taking a boat and we not go through any security channels, well, that could be security breach. And that is something also that we need to be careful for when we do the risk assessment, that there will be no additional communication potential coming into that zone, which is not measured under any security means. So coming back here on the last bullet, while channels play a role facilitating communication between the zones, they are not typically assigned security levels themselves. Instead, security requirements for the conduits are determined by security levels assigned inside the zone they connected and the data they will transmit. Summary on that security and the counter measurement. So very similar as we just referred to the black channel. I took the picture here or the schematic that I just used for the black channel and I changed that. You will not find this picture as an example in the security standard 62443. It is just me as an engineer trying to compare the black channel approach also to what we see here in security. So very similar for safety with the black channel approach. In security, the security level will be achieved with the efficiency and the performance of that, again, the blue barrier shown over here, which is for us here the counter measurement assigned inside the zone and not to the channel. Right, Gabriele, we have one more poll question before we go into the pre-recorded questions. Right, so I have another poll question. towards security now. The question is, what is the purpose of defining security levels in the IEC 62443? Answer A. Again, only one answer is the most complete and the most correct answer. Answer A is to specify the performance of industrial communication networks and systems. That is the first answer. Answer B, to categorize the sensitivity of information requiring protection. Answer C, to define the required level of security for industrial segments and devices. And answer D, to classify the types of cyber threats industrial control systems face. All right, so we need to have a little bit more interaction. And as you already can, as Gabriele and I can already witness, this question is probably much too easy, but it doesn't matter. It just shows that people can still click a button. And thank you for those who are clicking the questions or the answers which are not often used, to be a bit diverse with the rest of the group here. I think we can finish the poll,
okay.
Gabriele.
And share the results.
Right, as you can see, no one actually clicked on the answer A to specify the performance of industrial communication networks and systems, which is great because that would not have been correct anyhow. We had here 6% clicking on answer B to categorize the sensitivity of information requiring protection. Well, that is not really correct. As you can see here, to the majority of the answers, on 71% answering C, to define the required level of security for industrial network segments and devices. And the last one, which was 24% here, we had answers to classify the types of cyber threats industrial control systems face. Well, again, here, the only correct answer, which we would consider as a correct answer, if this would be an exam, would be answer C, to define the required level of security for industrial networks and segments. Right, I will stop sharing this and I will continue. What can you take away here from this webinar? And I do realize it's quite heavy in theory, but there's nothing more we can do than just try to highlight you the fundamentals. What is now safe communication? What is now secure communication? So the connectivity, end of the day, that we're going to use between zones, if there's now a control platform or a BPCS, or it is an SIS, or it is maybe your asset management system that is actually trying to control how much profit that your plant is making. Well, whatever communication we are sending into that zone or we're reading from that zone needs to be actually secure, measured by the countermeasurements efficiency. Both the safety protocols give you the safety integrity, and the countermeasurements will give you the security efficiency. That is totally both independent from the transmission medium. And I made there an example from in the recorded question. That is what I was thinking was coming in here, but it is in the recorded question, which I will show you in a minute. So as a summary, actually the title here, apologize for that. The left title, I need to make a note on slide 30, because that has nothing to do here with the minimum HFT. That should have been here a summary. Anyhow, what GMI can help you with is in terms of the 6, 15, 11, as you heard Gabriele saying, one of the services that we deliver is not only consultancy, but also training. And the first slide is all about the consultancy. So we do provide in the life cycle activities, some consultancy for the 6, 15, 11, which is listed in here. I will not read all that. And the last bullets here are for security. So we also have specific security specialists that can potentially help you to make a security risk assessment. Part of my own role still inside GMI is to provide the functional safety competency review training from TOV Ireland. And under the umbrella from TOV Ireland certification scheme, we also provide the cybersecurity fundamental training and security risk assessment. And recently new by 2023, but we really focused to push it in the market in 2024, is the last bullet over here. And the main reason for that is we are combining those two trainings from 3.5 days into 4.5 days. So in other words, we are actually having a condensed training program with 4.5 days based on the fundamental training. We'll be giving some reference, some resources that will be requiring some self-study, or you already have the know-how of the fundamentals. So we're only going to review that in the first day in the fundamental recap of all the basic requirements that should be known. And then on day number 2, 3, and 4, we will go to the full-blown security risk assessment training course. And on the last day, we give you an exam for both and the fundamental and the security risk assessment. All those training courses, all those 4 are subject to a piece of paper called certificate based on a successful completion of your exam. And of course, we also do customized in-house training and webinars as you are following here today. For those of you who are knowing this book in the market, that's the SIL manual from GMI, currently still in the 4th edition. If you would open the page of the 4th edition, one of the first pages will show the authors. I got my name under chapter 7 and 8, where chapter 7 is the executive summary of the 6.15.11, whereas chapter 8 is a summary of a safety requirement specification. Okay, before we're gonna close, let me share with you the pre-recorded questions from the registration. And that's what you should see now, if everything goes well. Let me open again the participants. Okay, so, oh, hang on, we should not be at thank you, we should be at the beginning. So let me go back, sorry for that. Here we go. So the first question that came in of one of the engineers that registered for this webinar was asking safety protocol versus black channel communication and possible impact on SIL application and validation. Of course, now, if you read the question now, you just have heard the webinar, you would be able already maybe to answer, but this is coming in even before we started the webinar. So there are engineers who are already thinking, what is now the protocol versus the black channel? What is here the impact on SIL? As we showed you on the webinar itself, the safe protocol communication involves using communication protocols that have built-in safety mechanisms and features, especially designed to ensure reliable transmission of safety critical data. Explain it simple. If on the left-hand side, component A needs to send a message to component number B, we need to make sure that before component B will do something with that data, that this data is actually correct, reliable, not corrupt, not being changed, etc., etc. So somehow, with our protocol measurements, we need to actually find a, let's say, as we call it here, a built-in safety way that component B will take data coming from component A and will do the right action with that. And potentially, before component B will be allowed to carry out what component A was asking, potentially there will be some handshaking, of course, in between, and B will tell A, that is what you want me to do, and A will say, yes, please carry this out. So that's in a simple explanation what those protocols will make sure in terms of the 6.15.08 that this data is reliable to be used from one component to the other component. The channel medium, as we already told you, doesn't really matter. So based on the black channel doesn't really matter. Based on the white channel, of course, 100% relies on the 6.15.08 compliance. But if you're using a black channel communication, that is the channel itself is considered black. In other words, in terms of the internal loop operation, that means that the message, once it leaves the protocol inside the element from that component A, in my example, and it used that protocol, and the protocol is sent to the other side, once the protocol is used again inside that component B, based on the protocol in measurements with the 6.15.08, needs to make a decision if it is safe to use this, yes or no. There are currently safety protocols already certified up to a certain SIL level, if that was the question that I thought to understand. It goes up to SIL 3 compliance, like as an example, giving here the Profi Safe. The second question that came in was safe data transfer over various mediums. Again, we have answered that very clearly, but I like to repeat this here again. And that is the one I just had in mind that I made an example. In the context of the black channel approach, the specific medium that is used for the transmission of the data becomes irrelevant, providing, of course, that the carrier ensure reliable communication, in other words, using the protocols in terms of 6.1508 compliance. And I made an example, and pure as an example. It's not specifically to show you a solution, but to give you an idea. What is, for instance, on the market? This could involve employing a wireless connection, and the wireless connection can be based on the ISA 100 protocol. And the ISA 100 protocol is not safe, but the ISA 100 protocol is known to communicate. I mean, that's one of the communication protocols accepted in the market. And what they can do is, for instance, as a solution, they can incorporate both safety and cybersecurity consideration. As an example, they can use a Profi Safe tunneling that they will enter into the ISA framework, the ISA 100 framework, enabled to communicate from one component to the other component. And because they can use here the Profi Safe tunneling mechanism, they can use this up to SIL 2 communication, aligning with certain guidelines that are outlined in the 61784, which is the functional safety for field buses. Conclusion: the safety of the message packets is determined by the protocol, whether it is transmitted via wire, fiber optic, Modbus, Ethernet, wireless, or any other means. And I put this question in there with a great pleasure because I had an engineer asking the question, what is the impact of APL? And I will explain for those who are not familiar to the abbreviation what it means. But what is the impact of the APL on this webinar topic in long term? Well, again, I don't have a crystal ball here in front of me. So what is the impact on the long term? I cannot predict, but I can look back what happened in the meantime. As I started my career as an instrumentation engineer in the mid-80s, the mid-80s instrumentation with today's instrumentation is a huge difference. State of art, what was then mid-80s state of art, was a 4 to 20 milliamps that we were dealing with. That's actually for the second slide. Let me finish that story on the second slide. Let's first look and define, for those who are not familiar with APL, what it stands for. It is based on an Ethernet advanced physical layer. And it is one of the latest, between brackets, greatest wired media that is being promoted, that is based on a two-wire loop-powered Ethernet physical layer. In other words, you're going to have two wires that you will have and your field power and your communication on two wires using this 10 base T1L, which stands for the 10 megabits per second. So in other words, fast. In terms of distance, it can go up to 1 kilometer. And that is here where I put the source. That was maybe I just confused to the different picture in the webinar itself, but I put here the source. So if you go to the ethernetapl.org, which is here the link that will be in your PDF, you will find or recognize this picture where they compare all the different, let's say, communication speeds with the latest one, which is of course here the fastest and also the longest cable, providing power and communication on a two-wire. Finishing on my story that I just started on my mid-80s as an instrumentation engineer, the state of art at the time in the 80s was a 4 to 20 milliamps. Because in my beginning of my career, when I had to calibrate a pneumatic controller as an example, well, that was not my favorite thing to do. If I would have to have a 4 to 20 milliamp transmitter with some electronics, that is what I would prefer as an engineer from the 80s. Now, if I look at and I gave a classical example, if I look at the field transmitter or a pressure transmitter from the 80s, we used to have two screws to calibrate a transmitter. It was the zero and the span. If I look at a modern transmitter today in the field, how many different digital settings do you have in one field device that the engineer will have to take care of? In other words, or in a summary, to make a long story short, the devices today becomes very, very, very complex. And very often so, the devices' complexity are increasing a lot faster than the competency of the engineers in the field. In other words, we are lacking awareness and competency of engineers with the state of art available today on the market. Going one step further, what happened in the past already, from the beginning to today, well, that is today's world. And as you can see, we are moving on technology, on media, on the measurements, on the local access to data, and on the remote access to data. We are actually moving in a complete different world now. And the Ethernet APL, there was the latest Namur, let's say, meeting end of 2023. Whereas the vendors were promising to be ready with their devices yet, it looks like that many vendors are not yet there to be ready to actually communicate with APL, let's say, protocol as they were hoping to be in 2023. So what will be on the long-term vision? I cannot answer that. I can just say it is a new technology. We can certainly not stop it. It is in the market. There are already, let's say, major vendors involved in able to have interfaces ready to communicate, but the device manufacturers are a little bit lacking behind. But I personally believe certainly it is also coming for the future. So Ethernet APL can also facilitate standard compliant safety data exchange. There is already some APL, let's say, communication up to SIL 3, communication using ProfiSafe and Profinet. And if you want to have a lot more, let's say, detailed information, I would here advise you to go into the ethernetapl.org website, which has lots of information already available. Right, we have one last poll for Gabriele.
Yes, you should see it.
And that's typically on the webinar feedback to see what is your likings or dislikings of the feedback. And of course, you don't have to comment on the feedback. You will have to do that yourself, and then Gabriele can summarize this for me.
Let's wait a couple of more clicks. Okay, and I can share the results. So thanks for the good feedback.
Well, at least it's probably an honest feedback. It's the first time that we have not a majority on answer A. So that means that maybe this topic potentially was maybe not ready for the audience, or opposite. The webinar was not maybe up to the level that the audience were expecting. But of course, you still have to consider we do a webinar in 60 minutes, where we have about 35 to 40 minutes max to explaining some technical items. If this would be a proper training course, I reckon that safety protocol and countermeasurements probably would take anything between a half day to maybe 5 to 6 hours max. That is how detailed we could explain. But that is why we keep a webinar, just to a teaser to give you some of the information. Anyhow, thank you for your interaction. Thank you for the feedback. Did you share the results already? Yes.
Yes, yes.
Okay. All right. So let me go back, and then all that we can do is saying thank you again for following this webinar, and up to the next one next month.
Next month, right? Yes.
Thank you, Gabriele. Thank you, everyone.
Thank you. Thank you, everyone. Have a good day.